We're out on a site today where we've been working with the University of Minnesota on a Cooperative Ecosystem Studies Unit project for the last 3 or 4 years. We've had a lot of challenges with regenerating trees and not really sure what the problems are, and so we wanted to put in an experiment to test some of the main ideas about what the problems are with forest regeneration. We've got 4 species in this planting. This right here is a swamp white oak that I'm standing next to. We've got silver maple, hackberry, and American sycamore. We're right now out here measuring those trees kind of to start with, so that we have a reference point to say this is how big the tree was when it was planted, and so we can start to look at which trees survived, which trees died.
It's good to know, are they dying early in the year, they're dying at a drier point, at a wetter point, and we can really get an idea of kind of the certain difficulties that each seedling will face in regards to those conditions, and also canopy, and then also things like other plants that will eventually grow up much taller than this seedling. Are they inhibiting the growth at all later in the season?
Reed canary grass, you can see I'm about 6'2", something like that, and you can see that the tops of these plants, some of them are higher up are taller than even I am, and the leaves are up to about 3 or 4 feet. And if you kind of, it's completely covering the ground. There's no sunlight that's reaching the ground. One thing that I see quite frequently is stinging nettle, which can be 8 or 10 feet tall, filling up a gap like this, and then again it's creating shade on the forest floor that prevents tree seedlings from becoming established. Probably our highest goal for the management that our office does on the river is trying to get a younger group of trees established on the river and try to replace as many of these reed canary grass dominated gaps and areas with native tree seedlings that will be there for the next 100 years or 200 years.